This lesson, I'm going to give you two ways of doing the same thing. You do need to know how to do both methods because they can ask you to do either of them in the exam. But there will be questions where you are free to choose which method to use, in which case you can pick your favourite one. So what we're doing is given a polynomial, so in this case, given this quadratic here, x squared minus 3x minus 5 equals 0, we're going to find a new polynomial that has roots which are related to the original one. So if the roots of this one are alpha and beta, we want to find a new quadratic which has new roots alpha minus 2 and beta minus 2. Now what you don't want to do is calculate alpha and beta, subtract 2 from those, and then use those to get a new polynomial. That's not what it wants you to do. Instead, we're going to use either sum and products roots method or a substitution method, which we'll look at later on. So here are the steps for the sum and products of roots method, which you can extend to cubics as well. First off, we're going to write down alpha plus beta and alpha beta for the original equation. I'm not going to call them minus b over a and c over a at this point because it will get confusing later on if you do that. So alpha plus beta is equal to minus b over a. In this case, b is minus 3 and a is 1. So I can write down that's equal to 3. Alpha beta is equal to c over a, which is minus 5 over 1. So I can just write that. So if we call our new equation ax squared plus bx plus c, I'm going to write down now my results for minus b over a and c over a in terms of alpha and beta. So from our new equation, this has roots alpha minus 2 and beta minus 2. So I've got alpha minus 2 plus beta minus 2, which I can combine together to give alpha plus beta minus 4. Similarly for c over a, that's equal to the product of the roots, so alpha minus 2, beta minus 2, which I can expand to get alpha beta minus 2, alpha plus beta plus 4. So if I expand this out, I'll get alpha beta minus 2 alpha minus 2 beta, but I can factorize alpha minus 2. So alpha beta minus 2 alpha plus beta. Now we know the value of alpha plus beta and the value of alpha beta. Earlier on we said alpha plus beta was 3. So here 3 minus 4 gives you minus 1. And we said alpha beta is minus 5. We've got alpha plus beta is 3, so that's 2 times 3 plus 4. So that gives me minus 5 minus 6 plus 1 minus 7. Now that we've got values for minus b over a and c over a, we've got 2 equations and 3 unknowns. We can pick one of these letters to be anything that we want. So we're going to pick a to be 1 in this case, which is a sensible choice. And then that allows us to work out b and c. So if a is 1, minus b equals minus 1, so b is 1. And if a is 1, c is minus 7. This allows us to write down the new equation, which will be just x squared plus 1x minus 7. We'll find it without the scaffolding now. So we've got a quadratic here. We're finding a new quadratic with roots 4 alpha minus 1 and 4 beta minus 1. So first off, I'm going to write down alpha plus beta and alpha beta from the original equation. So alpha plus beta is minus b over a. Don't write minus b over a, but we end up with minus half for this one. We've got minus 1 over 2. Alpha beta is c over a. Well, c is 9 and a is 2, so you get 9 over 2 for this one. For your new equation, ax squared plus bx plus c. And write down first minus b over a. So minus b over a is the sum of the roots. The new roots are 4 alpha minus 1 and 4 beta minus 1. Type this out. 4 lots of alpha plus beta minus 2. And alpha plus beta is minus a half. Substitute that in and evaluate that, I get minus 2. We can do the same thing for c over a. So c over a is the product of the roots. Multiply these together and expand them out. 4 alpha times 4 beta gives me 16 alpha beta. I get minus 4 alpha minus 4 beta, which I can collect it together to give me minus 4 alpha plus beta. And minus 1 times minus 1 gives me plus 1. I know the values of these. So alpha beta we've got is 9 over 2. Alpha plus beta is minus 1.5. Plus 1 gives me 75 for it. We've got two equations with three unknowns, so I'm free to pick A to be whatever I want it to be. So these are all integers, so it makes sense to pick A to be one. If you're fractions, it might make sense to pick A to be the denominator instead. If A is 1, that tells me minus B equals minus 4, so B equals 4. And if A is 1, that tells me C equals 75. So my new equation is 1x squared plus 4x plus 75 equals 0. This question for you to have a go at. It is a cubic, so it will be a bit longer, but use the same principles to have a go at this one. Pause the video while you're doing so, and I'll reveal the answer in a second. This one you need to write down results for alpha plus beta plus gamma, some of the product pairs and the product of the roots. You'll need results for minus b over a, c over a, and minus d over a. Do all the algebra, substituting your results, and you should get a is 1, b is minus 15, c is 68, and d is minus 86. Now, the other thing you need to be able to do in this pack is use substitutions to do similar sort of things to come up with new equations and maybe solve them. So this question here, I'm going to use a substitution to solve this by hand. Obviously, this is a cubic that you can solve in the calculator, but just to justify that substitutions are useful when it comes to polynomials. This asks us to use the substitution x equals u minus 5. So I'm just going to substitute that in and expand everything out. I'm going to use the binomial expansion to expand u minus 5 cubed, so you get u cubed minus 15u squared, so that's the minus 5 times the 3 from the binomial, plus 75u, and then minus 5. Do the same thing on this one, so I'll get 15u squared. When I expand this, I'll get minus 10u, so I get minus 150u, and then I'll get plus 25 times 15, which is plus 5. Expand out 71, so plus 71u minus 25 plus 105. Some of this stuff will cancel, so the u squared terms will cancel. If you add up all of the number terms, they will also cancel as well. So you're just left with u cubed. The u terms, you've got 75 plus 71, which gives you 146, but minus 150 gives you minus 4. These can solve on your calculator if you must. Three solutions: use 0, 2, or minus 2. We know that x is u minus 5, so taking 5 off all of these will be minus 5 and minus 2. And minus 7. You can check those. The point is that you can use substitutions to solve some polynomials. Now, what this is also useful for is for finding results related to the roots. So these three things here, this alpha plus 5, beta plus 5, alpha plus 5, what you could do is you could expand them all out and simplify and use the result from the original equation. Or you could notice that these are the roots of the new equation. If the substitution is x equals u minus 5, then you replace x with alpha or beta or gamma, you get u equals alpha plus 5 or beta plus 5 or gamma plus 5. So these are all the roots of the new equation. Now this first one, alpha plus 5, beta plus 5, gamma plus 5, is the sum of the roots of the new equation. So that's equal to minus b over a, the new equation. Well, b is 0 because there's no x squared term, so that was just 0. This one is equal to c over it, so sum of the product pairs for the new equation. And c is minus 5, and it's 12. And this one here, the product of the roots of the new equation, this is equal to minus b over a, but again, d is 0, so you just get d is 0 for this. So first off, we're being asked to use a substitution to transform this equation. So literally again, just going to substitute in 2 minus 1. Expand this out, so I'll get 36u squared times 2 is 72u squared. So I get minus 12u for that's what I see, and I'll get 1 minus 2. Minus 18u plus tidy this up so I'll get 2u squared minus 42 plus 10. So I'm just going to leave that. Then hence find the value of this thing here. What you've got to notice is that if x or alpha equals 6u minus 1, if you rearrange this to make u the subject, you get u is alpha plus 1 over 6 or beta plus 1 over 6. So this is equal to the product of the roots of the new equation. Now the product of the roots of the new equation is just equal to c over a for the new equation. And so that's 10 over 72. Or 5 over 50. And we've got this cubic one here, very similar sort of thing. Pause the video and I'll reveal the answer. Substitution, get the cubic down here. And this is equal to the sum of the product pairs of the roots. That's equal to c over a for this equation, which gives you just 12 if you use those coefficients. Now here's how we can use this method to do the same thing as we did with the sum of roots and product of roots while finding new equations. So we've got exactly the same question here. I'm just going to do it differently. If we're finding a new quadratic with roots alpha minus 2 and beta minus 2, I can say our new quadratic will be u equals x minus 2, because x is equal to alpha. And I can rearrange this to make x subject, so I know what to substitute in. So add that 2 across in this case, which is x equals u plus 2. We put this into the original equation, so u plus 2 squared minus 3u plus 2 minus 5. I can expand and simplify this to get the quadratic equation. So u squared plus 4u plus 4 minus 3u minus 6 is 5. U squared 4u minus 3u gives you plus u. 4 minus 6 minus 5 gives you minus 7. That's the same equation as we had earlier. Put this into practice now. So we've got a cubic here. Notice there's 0x squared, which is my in. Find a cubic with these new roots here. So I'm going to work out what the substitution is. So u equals 2x plus 1. And rearrange this to make x the subject. And x is u minus 1 over 2. Substitute this in. So u minus 1 over 2 cubed. Didn't actually need that 0x squared. So 4u minus 1 over 2. Right, 0. I'm going to do the over 2 cubed first. That gives me 8. So I get 2 over 8 outside. And expand this out using the binomial. So u cubed minus 3u squared plus 3u. This one. 4 over 2 just gives me 2 here. So this will be 2u minus 2. And then plus 5. 2 over 8 is a quarter. And then I'm going to times everything through by 4. So cancel out on this first ones. Then times everything here by 4. So 2u times 4 is 8u. 5 minus 2 is 3. Times that by 4 is 12. Type this up. So I get u cubed minus 3u squared. Then 3u plus 8u is 11u. 12 minus 1 is equals to 11. And this is the new cubic equation with those roots. There's a question for you to have a go. Pause the video, have a go at it, and I'll reveal the answer in the